Hello, and welcome to this tutorial on the event system and ownership in Worlds. In this video, we'll explore how to create more responsive and interactive experiences by enabling communication between entities. Imagine a player pressing a button and watching their view transition to a cinematic perspective of a door dramatically opening. Creating this experience requires two fundamental skills we'll cover today. The first is listening to events from the button press, and the second is managing ownership to control the player's camera view. I'm Andy, and this video builds on our previous tutorial about how scripting works in Worlds. Now that you understand components, we'll take your creations to the next level by showing you how to coordinate behaviors between different entities, create responsive dynamic interactions, control which player can manipulate specific world elements, and enable synchronized multiplayer experiences. We'll explore different types of events, sending and receiving events, why ownership matters, and practical methods for transferring ownership. This content is designed for creators familiar with Worlds, TypeScript, and the different scripting APIs. Ownership is a fundamental concept in Worlds that determines where a script gets executed. In Worlds, there are two types of ownership. There's server ownership, meaning the server is responsible and authoritative for updating the entity's state. And there's local ownership, meaning the client, which could be a user's headset for VR users, or it might be in the cloud for mobile and desktop users, since there's no native application, is authoritative for updating the entity's state. By default, all entities in your world are owned by the server. This design ensures visual consistency for all players in the world, and it prevents cheating or manipulation in multiplayer experiences. Ownership directly impacts how responsive your interactive elements feel to players, and here's why that matters. Server-owned entities have their logic executed on the server, and this ensures fair gameplay and consistency across players, but it introduces latency between the player input and the visual feedback, because when a player shoots a target with server ownership, the server detects the collision of an entity, the server then plays an explosion effect, and finally the results are sent back to the client. This sequence creates a noticeable delay that feels sluggish. Locally owned entities have their logic executed on the player's client, and this provides immediate feedback and more responsive interactions, and it's perfect for interactions where tight control and responsiveness are critical. For example, when a player shoots a target with local ownership, the server detects the collision of an entity, and the client immediately plays the explosion effect for instant feedback. Generally, any mechanic that requires instant responsiveness will involve some type of ownership transfer. For example, player-controlled vehicles and weapons, personal UI elements, and custom player controls, including the camera control and focused interactions. These specialized capabilities, we'll cover them in future tutorials. To leverage ownership effectively, you need to understand script execution modes. So there's default scripts which run on the server, and changes sync automatically to all players, and those are the best for most gameplay logic. Alternatively, there's local scripts. These are required for transferring ownership of the script execution and execute on the owning player's client. Field variables will reset every time the ownership is transferred to a new player. Variable data can be preserved by using specialized component methods like transfer ownership and receive ownership, and they enable access to client-specific APIs. You can change the execution mode of a script through the desktop editor. So let's take a quick look at how to do that. In the desktop editor, I currently have open the Camera API example world. And if I click on the drop-down for scripts, I can see all of the different scripts in the world. Let's look at how we might change the where the script is executed on one of these. So I'm going to look at the gun script. Let's click the three dots next to it, and if I scroll down to execution mode here, you can see that the gun is executed locally. Alternatively, let's have a look at the player camera manager. If I click on the three dots here, the execution mode is set to default. So the gun script is executed locally because we want that immediate feedback from the VFX of the gun, whereas the player camera manager is executed on the server because we want the players' cameras to be managed, who has what camera to be managed by the server. Individual cameras in this world are under the player camera, and you'll see that that's executed locally. It's worth bearing in mind, for mobile and desktop players, both default and local scripts execute in the cloud, since there's no native application, unlike VR players where the local script will run on the headset itself. So this can really impact performance considerations when you're designing for cross-platform experiences. There are several ways to change who owns an entity. You can do entity.setOwner, and that changes the owner of the entity, but it also resets all the script variables to their initial values. You might want to use entity.setOwner within a collision, so the ownership could be transferred on the collision event, as long as the properties of the entity are configured with this condition. Also, ownership can change with grab by player, so when you grab it, it's attached to the player. When ownership changes for a local script, all variables reset to default values unless using the transfer receive methods. Here are some considerations for the transfer receive methods. Component.transfer ownership parameters are from player and to player, and they return a serializable object that contains any values you would like to persist for the new owner. Component.receive ownership, the parameters are the serialized payload from player and to player. From here, you can assign the payload values to the field variables so they can be used to the other class methods. Let's have a look at where we use receive and transfer ownership in our Camera API example world scripts. So if I look at the player camera, we know that the player camera executes locally, and within the script here, we've got this receive ownership function, and this is actually called directly by worlds. And you can see it's got 3 parameters where it passes a serializable state, which could include all of the values that we want to pass from one owner to the other, as well as who this used to be owned by under the old owner parameter, and who now owns it under the new owner parameter. You'll see in the Camera API examples world that we initialize the camera listeners when this happens. So when my player camera has transferred ownership to a new player, I'm going to need to make sure that I'm listening out for the events that can happen to that player. So if we look at this function, this is where I set this up because we are listening for events, network events, that are being sent to the player specifically. So when we're transferring ownership, in the Camera API example world script, I'm going to take a look at the gun script, and in here we've got onGrab, and in the onGrab event you can see, which is called when a player grabs this gun, you can see that I'm setting the owner of the projectile launcher by using .owner.set on the projectile launcher. Similarly, you can see this with the player camera manager. When a new player enters the world, we actually get a camera from a list of, from an array of cameras, and we set the owner of the camera here. This is because the player camera script and the entity that holds it is locally owned, because we don't want the camera script to be affecting anyone else except the individual player who the events are working for. So now that we understand the basics of ownership, let's move on to another fundamental skill, sending events. The event system is how different parts of your world communicate with each other. Events are essentially messages that can be sent to share information or execute behaviors, like between different entities and from world interactions to entities. Think of events like mail carriers delivering messages between houses in a neighborhood. They allow separate parts of your world to communicate with each other. Worlds provides 3 main types of events. Local events, these are used for communication between entities that belong to the same owner. For example, a trigger gizmo and an audio gizmo that are both owned by either the server or a player. These are equivalent to direct function calls. There's also network events, and these are used for communicating between entities that belong to different owners. For example, a score manager component owned by the server sending the player's score to a custom UI owned by a player. Network events are essential for multiplayer interactions, but they are also subject to network latency. And finally, code block events. These are used for listening to the built-in events and interactions with entities and players, such as entering a trigger, grabbing an object, the player entering the world, and much more. When sending an event, you need to consider the event name, what you're sending, the data payload, which is what information to include, and the target, who will receive it. Different event types support different data formats. Local events can send almost any data type supported by TypeScript. Network events are limited to serializable data, numbers, strings, simple, object, Horizon-specific classes, such as player, entity, vec3, and quaternion. So with the Camera API example world, let's have a look at where we are sending some different types of events and where we're creating them too. So if I look at the camera trigger, which essentially is attached to a trigger gizmo in the world, when a player walks into the camera trigger, it sends an event that forces the player camera to a different mode. And you can see I'm using a code block event. I'm listening for the code block event here with the this.connect code block event. This.entity will refer to the trigger gizmo in this case. And the event I'm listening to is the onPlayerEnter trigger code block event. What happens next is this then sends a network event. This camera trigger is executing on the server, and I want to make a change to the camera, which is locally owned by the player. So I need to send a network event to the player's camera so that I can make that change. So here I'm sending this network event, and you can see how I've created a network event. If I control click on that, we can see I have this group of events here. The first one, set camera mode, is a network event. And all I'm doing is passing a camera mode, which is just a number. You can see the camera modes here. So that's a network event. Let's have a look at a local event. A local event happens in something like the door cutscene. You'll see there's a couple of local events that are defined at the start of this script. On start cutscene and on cutscene complete. And essentially what we do is when the player presses a button in the world, we are sending a local event, which is owned by the server, to the player, to the door cutscene, and that starts the door cutscene. So let's have a look at that in action. If I just preview from here with my avatar, I'm going to climb to the top of this group of blocks, press this button, and that then triggers the door cutscene. So I've pressed the button, which is executing on the server, and then I've communicated to the player's camera to switch to a fixed camera mode, but move it along this path. But regardless of event types, here are a couple of tips to keep in mind. Do not use code block events for ad hoc scripting communication. Ideally, keep code block events for only listening to the built-in interactions. And be mindful of event volume. Sending too many events can affect the performance of the world. To receive events, you need to set up event listeners. Define a new event, either a local or network one, depending on your ownership needs, and then connect the event to the component using one of the connect event methods. Pass in the class method that should execute when the event is received. Make sure you have correctly defined the expected parameters, because incorrectly defining those expected parameters on the receiving function could lead to the method not being called, and there won't be any errors in the console. Event listeners are typically set up in the pre-start or start functions of your component. Local and network events can be sent in two main ways. You can either send them directly, which is a direct event sent to a specific target, like a specific player or entity. These are more efficient as the messages are only communicated to the intended recipient, and they're useful for when you know exactly which target needs the information. For example, a projectile that hits and sends an event to a target. Conversely, there's broadcast events, and these are sent to all scripts that are listening for that event. These are useful for when multiple parts of your world need to react to the same event. Broadcast events are less efficient, but they are more flexible. For example, you might want to broadcast a game over event so that multiple UI elements and game systems know when the game is over. When working with events, keep these best practices in mind. Use clear, descriptive event names to make your code easier to understand. Be mindful of event volume. Sending too many events can affect performance. Be cautious when sending events in a loop. There's a limit to how many events you can send in a single frame. And consider ownership when planning your event strategy. Events behave differently depending on who owns the script. Network events introduce latency. Design accordingly for time-sensitive interactions. And local events are more efficient than network events due to the fact that local events are processed immediately, but network events can also incur network latency. For more detailed information about performance considerations, refer to the Events Best Practices documentation. In this video, we've covered essential concepts for creating responsive, interactive experience in worlds, the basics of ownership and why that's relevant for creating responsive interactions, and how the event system enables communication between scripts and interactions, and best practices and considerations when using ownership, local script, and events. These tools give you the ability to create worlds where an entity can respond and coordinate behaviors across one or more players or entities. Now that you understand these concepts, we encourage you to experiment with ownership transfers in a simple test world, practice sending and receiving different types of events, build a small interactive project that combines these techniques, and I'd encourage you to complete the batting cage tutorial and start with simple implementations before tackling more complex systems. Also check out the Camera API example world to see how you can link different types of events together and follow those event paths all the way through the code to figure out how it works. Remember that understanding ownership and events is foundational to creating sophisticated interactive experiences in worlds. Thanks for watching. I'll see you in Worlds.